Hi, are you looking for how to design and develop a data science dashboard on cloud infrastructure for analysis and monitoring of business data? Uh, Today, we can use machine learning open source tools and frameworks such as ML.NET, Jupyter Notebooks, Python, Scikit. And for this, today at the AI Journey, we have a special guest, Antimo Musone. Hi, Antimo.
Hi
Please
guys.
introduce yourself.
Hi guys. I'm Antimo Musone, senior manager of EY Italy. I'm a digital expert with 15 years of experience. I'm an expert of cloud computing and machine learning, co-founder of Italian.NET community and 15 Genium startup.
So you are an expert.
Yeah, always.
Today we are lucky because there is another expert, Gianni Rosa Gallina. Hi, Gianni.
Hello, everybody. Good morning. I'm a senior software engineer in the Deltatre Innovation Lab, working on R&D stuff from machine learning and AI deep learning up to cloud workflow, video workflow, and also exploring cutting-edge technologies and mixed reality stuff. Today, I'll be behind the scene with Clemente, helping on monitoring the social network for your questions and directing all the talks with Ant.
So too many experts today. Anyway, we
We
can
can start.
yes.
Okay. I can start with my contacts. My contacts below. You feel free to contact me on LinkedIn or email, or there's my phone in below. It's small, but you can see. Okay. Now, we can start with our part on machine learning tools and frameworks. In particular, the first step of this part, starting with Jupyter. Jupyter is an open source software. It's an open standard for machine learning. It's a tool, it's a framework, it's a platform that you can use to create in previous step to analyze data and to create fantastic machine learning model in different languages. For example, Java, Go, Ruby, and so on. This framework, this platform, you can use on your desktop, on your cloud computing. In particular, today we use this platform on Microsoft Azure. Microsoft Azure offer different types of services to host Jupyter. You can host Jupyter on a virtual machine, or you can use platform services like Azure Machine Learning Services. In our demos today, we see Jupyter on DSVM, is a data science virtual machine. Today we see a demo about COVID, about a dashboard to analyze data from COVID-19, and we use different language. In the first demo, we use Python and Pandas. In the second demo, we use CSharp. So, before to start with our demo, just a little introduction to interactive computing. Interactive computing, what means? Interactive computing means the immediate exchange of input and output between computer and the user. It's a pattern. It's a pattern implemented by IPython. IPython is today is a standard from different language implement interactive computing. Today we have the IPython 4.0. It's the last version of this standard, and with interactive computing we have a best experience with computing. We can do a fast, a rapid interaction with the machine. Our code is immediately executing and give us an output. So this is a Jupyter architecture. We have three components, three main components: client, Jupyter services, and the kernel. Client is our browsers or is a desktop application. Jupyter services is the platform of Jupyter, and finally kernel. Kernel is the main core of this platform, and you can use different kernels for different languages. Today we have a kernel in C#. So before to see C# on Jupyter, just a little introduction to ML.NET. ML.NET is an open source, a cross-platform for machine learning. Is one of the best choose for .NET developers to create new machine learning models. You can use C# or F# to build your fantastic machine learning model. ML.NET also offering different capabilities, different feature. For example, AutoML. AutoML that enable you to build, training, and deploy machine learning models in a few minutes. And also, we can use with ML.NET different frameworks like TensorFlow, Onyx, and so on. ML.NET came with different example, different feature and business case. For example, you can use for sentiment analysis, object detection, sales forecasting, anomaly detection, fraud detection, and so on. For different types of machine learning, from supervised, unsupervised, and also for reinforcement learning. So, C# for Jupyter. It was announced the last November in 2019, and now is in preview 2. We can use in preview 1 we can use C# and F#. In preview 2 we can use also PowerShell. So you can write your notebook Jupyter with C#, F# and PowerShell. It's very simple, the installation. You must use .NET Core 3.1, and you also install Anaconda. If you don't know Anaconda, don't worry, but Anaconda is one of the best platforms for machine learning. You have two versions, a community version that is free and the enterprise version that is paid. But in this case, Anaconda born to make easy life of data scientists. In particular, with few commands, you can build your machine learning environment. Up this machine learning environment, you can use .NET Core and ML.NET to build your .NET notebooks. So before to see some demos, I want to suggest you some free links to test Jupyter. The first is my binder, is one of my best favorites. The second is Azure Notebooks. It's the free version of machine learning services, or Azure Machine Learning Services. And the last two, but not for importance, Colab is one of the best for Jupyter, and finally Kaggle. So before to start the data science experimentation, I want to show you my binder. So if you go in my binder, okay, my binder starts with this screen where I ask you to put a URL, a GitHub repository. Inside this GitHub repository, you can choose a notebook. For example, in this case, I prepare one notebook. I use a repository of Alex Amici. And in this repository that I can show you, This is the repository. In this repository, I have folders, notebooks with different Jupyter's notebooks, and I want to show you these. That is notebooks about COVID analysis. So I put the URL of GitHub, and after that I put the folder relative part with the name of Jupyter. So click on launch, and in this moment Binder is downloading the file, the notebooks, and is building these notebooks, and in a few minutes you can see the console. Okay, and in a few minutes we see a new we see these notebooks with we will see this notebook running, and we will see analysis made by Alex. So in meantime, I don't know if I have already built. No. Okay. In meantime, okay. So next, so data science experimentation. What does mean data science experimentation? Data science experimentation means to collect data, clean data, and engineering this data, and after building a machine learning data. We have different tools, different technology that we can use in analysis of data. For example, a map where we can see the correlation between data. Or we can use map. It's very important, the use of map. In particular, GIS software are very, very important today, because we can we want to map our data on location, and on this location we can make more analysis, more business. So we can use in our Jupyter Notebooks forum, that is an open source Python framework, that with a few lines of codes that you can see on the right, we can build a map, an OpenStreetMap. Or we can use IP widgets. That is a widget that are able to interact with our data. Or MOLA. MOLA is a Python libraries that turn your Jupyter notebooks in web application, a standalone application. I show you this example where I build a Jupyter notebooks, an analysis on COVID-19, and after that with MOLA I can offer these notebooks in web applications. So before I show you this demo, I want to say that I use dataset COVID-19 from Johns Hopkins University. That is a free public is a free GitHub repository. It's a public. I can show you. Okay, meantime, my Binder is also building. Okay, this is the public repository where we collect the data. In particular, we have data updated every day. We have a series of data or daily reports. Okay. So with this data, we try to analyze the different metrics of COVID-19, in particular the RT. RT is the effective reproduction number. R0 is a reproduction number in a general epidemic. It's defined as a number that suggests you if an epidemic is controlled or not controlled. If R0 is greater than 1, the epidemic is spread quickly. If R0 is less than 1, epidemic don't spread and disappear before everyone becomes infected. So with this notebook, we implement a calculation of these metrics. In particular, we use bias theorem and Poisson distribution in order to build a model of forecasting of this reproduction number. So I suggest you, Tino, you can insert this link in the chat, or you can show.
Yes, I will do it.
Okay. So if we go to this, so yes, sorry. Now you see the final output of my Jupyter Notebooks. That is the dashboard. The dashboard built on Voila. This is the final dashboard. The final dashboard. Sorry, but the title is in Italian, but it's very simple meaning. And if you see, I can, for example, interact with this chart with the JP widget. I can interact with my data. I can filter my data. For example, we have the top 10 of countries, so I can request the top 20. So, and finally, for example, we have a map, a dynamic map where I can put with volume my data. And finally, we have the calculation of RT. RT that is calculated with bias probability and the Poisson distribution. And finally, we have this. This is trends of RT in Italy in the last 2 months. Now, sorry, in the last from March until today. This is the trend of RT. So now I can show you the notebooks. So go. Okay. So this is a virtual machine on Azure, and this is machine on this machine I install Jupyter Hub, and in particular now I'm using the Jupyter Notebooks. I already created these files, and when I click on this, I open. So in the first part, we will see the libraries that I import from different frameworks, libraries of Python. I start with pandas, volume, matplotlib, seaborn, IP widget, and so on. So the first task of this notebooks is to read the data from the public repository of GitHub of Johns Hopkins University. So I collect different data set, and after that I display this data. For example, data about recovered, data about confirmed cases, and so on. After that, I try to make some correlation with a init map between different feature of this data. And I made some statistic very simple. For example, the total sum of cases in the world, the total sum of deaths in the world, and so on. So I want to show you only this, and after go. Okay, and finally, with volume, I create a map where I put the dataset that I collect in the previous steps. The line counts are very simple. I declared a word map that is an object or came from volume libraries. And in this map, I added different pinpoints, and that I show you in this. Okay. So this notebooks is running on Python 3.7. This is my kernel. I can show you different kernel.
Antimo, sorry
Yes.
for the interruption. The guy are asking if can access to this page. I believe that
You know, they don't access this page. They can now access only to my dashboard that is open, and it's open without any authentication. But this page with a custom authentication.
anyway, all the code and the slide deck will be shared on our GitHub.
Yeah. I give you all notebooks and all decks in order to download, and you can review.
Oh, perfect.
Okay. So in the meantime, you can check this dashboard on this link. Sorry, this is with IP, but the other link was this. This is the short link, build 2020 COVID. I don't know if, Tino, you put in the chat.
Yes, we added it.
Yes.
Okay. No. Okay, now we see a notebook with Python. Okay. But now I want to show you. Okay, this is okay. Just finish with this slide so we can focus on ML.NET. This is in this slide that I try to describe these notebooks. So in first step, we see the import of library. In the second step, I show you some charts. This is a bubble chart. Is a histogram diagram, and so on. This is a contagion trends that you will see inside these notebooks. This is the probability trend of RT value. This is the RT trend updated at 19 May. This is 11 June. And this is the 40 is today, 40 July. And as you can see, this RT is under the one, but is not yet under control. So we can see .NET notebooks. To show this, I go to my remote desktop. This remote desktop is a Windows Server machine where I install Anaconda. Sorry. This is Anaconda. Anaconda, it's an open source platform able to create different data science environment. In this case, I created two environments. One environment for Python, and the other environment for CSharp. This is a Anaconda navigator dashboard where you can launch different tools, different frameworks offered by this platform. All these frameworks are open source. We see Jupyter Lab and the notebooks, for example, but you can see RStudio and other frameworks. In this environment, we have a base root that is a Python, but we have another environment that Anaconda don't show in this moment because .NET Core for Jupyter is only in preview, but I can show you. So this is a Jupyter, okay? I can see my folders, my systems with different folders, and I can use Jupyter Lab. Jupyter Lab is the last version of Jupyter Notebooks. It's more user friendly and have more capabilities in order to discover data. For example, in this panel, I can see notebooks. This is in my notebooks, but I can see data. For example, I can see this CSV with a data set of data that we can use in our demo. In particular, these are used in sentiment analysis machine learning model, where we build a machine learning model in order to determine if a customer review is good or toxic. And we use this data set. And we build this machine learning model with CSharp. So, before to start with the final demo of CSharp, I want to show you a COVID analysis made by .NET. In particular, it's in this case is using the data frame. A data frame is the equivalent version of pandas in CSharp. Pandas is the best framework of Python to collect and to manipulate data in a matrix. So that frame is the last framework, is the last library of ML.NET in order to make a manipulation of data. Is also in developing, but is available for low function, but you can use. In this case, I can show you. I import a different namespace. The first namespace is Microsoft.ml, Microsoft.mdata, and so on. And finally, we use this namespace that is Xplot, that we can use this library in order to plot, in order to show some chart. In this notebook that I don't have much time to show all, but I can show you that I can make some edit. Sorry. Okay. So the first step is to select this shell and click on Run. This is an example of interactive computing. What that means? That when I click on this shell Run, I have a feedback of what's happening in this moment. What's happening? He tried to download and install different NuGet packages, in particular ML, Data, Plotty, and the CSV. You can see now that I'm installing these packages. This is the incredible feature of interactive computing. I have a web user interface where I send a command, I send different tasks, and behind I have a kernel that run this task and give me a feedback, a result that I can show you in this web browser. So I install all NuGet so I can run the import of this. Now go fast because we don't have time. I download the data. I format different data. This is very important. I try to load the data. These data are loaded from Johns Hopkins University, the same dataset that I use in Python Jupyter Notebooks. So I I try to download with a HTTP request with a HTTP client that it's a very common class for .NET developers. When I try to make an HTTP request and save these files on my folders, my file system. After that, okay, I downloaded. After that, loaded this data, and I want to show you this data. For example, now is updated to 7. Is not. It's all the data, but I can show you this. I have the data updated to 61. Yes, only because I choose the data. Sorry, I can. We have 16. Yes, okay. I want to download the data with different data. Okay, I'll try to. Okay, now I have downloaded the files of yesterday, and I can load and show you. Yes, the data now is updated to 7.14, and this is a new data. Yes, last updated. So this is only to show you that we can build this analysis with CSharp, and finally we can display this analysis with the plot chart. This is it's a common chart. This, for example, is top 5 countries of about confirmed cases of COVID-19. Or this is top country of about deaths, and so on. So now the last demo that I want to show you is the building of a machine learning model. In particular, I want to show you this. So, okay, in order to build a machine learning model, we want to define a class, and we want to define different input and output features. In this case, in this demo, I want to show you some example of definition of a class inside the Jupyter Notebooks. In this example, I build a class. I build a class with 2 attributes: first name, last name, and I put an instance of this class. But and click on execution, for example. I want to show the result. Camera is connected. Sorry, I try to reload. I think that this camera is dead, but don't worry, don't worry. Okay, I can choose a different kernel. In this example, I choose CSharp, but I can choose F-sharp or PowerShell also. So if I try to give okay, I don't know. Okay, so okay, it's working. Now I can put another attribute, for example, others get set. So and so and with this comment, I display the attribute of this class. I can add more items. So for example, I add another customer. For example, Luigi, address Milan. And so on. And finally, I have I can use exploited in order to display data. In this example, I display a basic bar chart, with animals of zoo, in particular animals of zoo for Rome Zoo, Milan Zoo. It's very simple, this framework to use, and this is an example in order to show this easy in order to build your chart, your analysis. So the final part of this exercise, in this final part, we build the machine learning model. In particular, we want to predict if a customer reviews has a positive or negative sentiment. We use a Wikipedia dataset, where that is composed by a review of a customer, and for each review we have a manual, a human label set to 0 if positive, 1 if it's toxic. This is the dataset. The dataset have these columns. We have a label that show if this comment is negative or positive. 0 is positive, 1 is negative. This is a dataset that I downloaded from Wikipedia, and I want to build a model that predict for a string in input if this review is toxic or positive. So go in our demo. The first step of our demo is import NuGet package for ML 1.40, and in particular we use AutoML feature. So we must install also AutoML and data analysis. So in a few seconds we have downloaded and installed these packages. When you see this is also running, but just a moment. Tino, we have some question.
Not yet. Of course,
Okay.
we invite to
Okay.
to ask us some questions.
Okay. So the first task after the install of a NuGet package is to create machine learning prediction model. Machine learning prediction model is composed by two classes. The first class is a sentiment issue that is composed by a label and text. It's the input of our model. I want to know if this review is toxic or positive. So I valorize the attribute of text. And the sentiment prediction. Sentiment prediction is the prediction of our model, and is formed by three attributes: predictions, that is a positive or negative, and is made by score and probability to specify the accuracy of these predictions. So go to the next. Okay, now what I'm doing is to collect this data set. So I have this data set in my folders. After that, I download this data set from this GitHub public repository. So I want the last version, and after that, I want to analyze this data set inside my model. My model that I created in 7 steps. 7 steps. In the first steps, I made some configuration, load configuration. For example, I set that the testing of the data is about 20% of all data. After that, I want to select the features of my models. In particular, features of my models, the input feature are text. Text is my comments. Step 3 is to identify the feature that I want to predict, the output, the feature that I want to show you when you put me this string, this text. Finally, I train the model with the dataset. I set in a previous step that only 20% of data inside the dataset are using for the test, and 18% is used for the training. So go. And finally, we have the prediction. I training my model, I evaluate my model, and finally I save my model. So in a very few steps, these steps is also running in this moment, is training my model. Just we must wait some few minutes. In the meantime, if you have some questions. Okay, all is running. So we are ready we are ready to test this model, and how we try this. We make a single test prediction. I create a class of a sentiment issue with a text URL locker, and I passed it to my model. So the prediction is that is a toxic sentiment, and the probability of being a toxic is 17%, 70.2. But now, if I change my initial sentiment and retry to test. In this case, I love you is non-toxic sentiment, and the probability of being toxic very, very, very low. So I finished my demo, and yes, this is described the part 1, part 2 of them that you see, but don't worry, we made available all download all notebooks and PPT to you in order to download and review at home. Any questions?
Yes. Okay. There is a Federico. They're asking for this type of implemented functions, such as a sentiment analysis. Which type of model use?
Yes, good questions. The model that we use in AutoML. We use in AutoML in particular. We use a binary classifications model, and we use the AutoML feature of ML.NET. And in this case, he tried to identify the best algorithmic, the best model that fit our issue. In this case, analysis of or the sentiment analysis, and he proposed the best in this case.
Okay, there is.
I would like to
yes.
something on that. If you want some more information on all the models behind ML.NET and AutoML, there is the official documentation from Microsoft that is very rich, so you can access to all information on that.
Yeah, correct, Gianni. And in fact, for binary classification, you have a list of a model that he used in these activities. Binary classification corresponds to a list of a model that AutoML automatically use in the training of your model.
There is another question by Federico. Is Altair implemented in MOLA?
No, in this moment is not implemented in MOLA. MOLA support only Python notebooks.
I have a question related to the C# kernel running in Jupyter. That's amazing, meaning that you can have this sort of, for those who already use Python for data exploration, data analysis, it's interesting to be able to use .NET or F# to perform exploration. But from there, how do you move your exploration to a production environment? Meaning you are satisfied with your code. Are there any tools or something is planned to easily move from those Python notebooks or C# notebooks, how we call that, and have a console application or something, or you have to perform everything from scratch and copy and pasting the code?
In this moment, you can only save your model in local. In this step, I saved my model, sentiment model, in a local. This is my zip, and inside this zip, you can use your model in a C# application in production or in testing environment. This is the only way today, but you can build the pipelines and MLOps in order to automatize these steps.
Great. And because I'm aware of some tooling for Python notebooks that can automatically export all your code from there and have the Python scripts, so you can easily explore stuff and then have something that you can already run in a Docker image.
Like TensorFlow serving.
Yeah, similarly,
Yeah, correct, yes.
So I was wondering, is there already something also for ML.NET?
Yeah, good. Yeah, a tool that from your model, from your zip, is able to create services in order to provide this, to all these services. For example, to your mobile application, to web application. Yes. it's a good idea. Yeah.
Antimo, there is another question about how to model. How to model, choose the model according to the task?
Because I set in this case binary classification. I choose I'm choose the task of binary classification because for me this task of sentiment analysis is binary classification. That means I want to predict if this label is a 0 or 1. So it's a binary classification, and the AutoML automatically decide inside the binary classification what are the best algorithms that fit your problem, that fit your data.
Perfect. Now, and is it possible to decide a type or a specific model to use?
Yes, but in this case we don't use AutoML. You can use the other feature of ML.NET. In this case, we use AutoML because AutoML in parallel execute different models in order to find the best model. But you can specify your algorithm. It's not a problem. But you don't use, in this case, AutoML.
In the meantime, we are sharing some links.
Yeah, all information related to models and which you can use, how you can use them, how you can train them. You can find everything on the official Microsoft documentation I was mentioning before. And also you can find a lot of examples, running examples. You can clone the repo from Microsoft with all the official documentation and examples and run yourself.
You can find all these samples from sentiment analysis to sales forecastings.
And
not bad.
Sorry.
Not bad because you can start from the scratch and you can learn starting from an example, and it's a good approach because the machine learning world is so complicated and required a lot of study. So I believe, I think also you, that is a good approach.
And there is stuff related to ML.NET that is, as you can use, of course, the notebooks to do experimentation, then move from, I was asking before, move in a console application or also in mobile application or websites, ASP.NET Core websites, all with the same model. The runtime runs, the runtime works.
Yeah, correct. With the same zip model. That I can show you this model that is my desktop documents. Oh no! Where is this? So. Okay, I try to download. This is my model that you can import in your console, in your web, on your mobile CSharp application.
And also you can convert it to an Onyx format and run it wherever you want.
So you can run everywhere with Onyx, yes, correct.
Is it possible to integrate Python libraries such as Scikit-learn in this application?
No. No, it's not. Today ML.NET is I offer you the possibility of use TensorFlow. No, not only TensorFlow and the Onyx models. Yep.
Something that maybe is possible, but I have not tried yet, is to mix and match C# code with Python code. But I don't know if it's already supported scenario in the notebooks currently.
Yeah, actually, these ML frameworks supported TensorFlow, Onyx, and so on. But in this case, I suggest you to convert your Scikit-learn models in Onyx, and after that use it in C#.
Okay. Few minutes before the end of this live. Anyway, I wanted to ask you about this different approach, because usually you're born as a developer, so usually you start from script file, code file, you build them, then you visualize the result, etc. You believe that this different approach can make the developer more productive? I believe that looking cell after cell the result is a good approach, but many developers lose the view of all the project. So from an engineering point of view, many developers are not writing a good code, because they are writing a code that they can see results after result. This is my point of view. The question.
The question?
Your question is, for you, this approach is good or not good? What are
For
the
me,
advantages?
it's a good approach. Interactive computing is the approach of interactive computing. Task after task, you can see the outputs. You have a more control and more focus on what you have done or what you are doing. Yes, but you can lose your focus on the end of project, but depends on the size of the scope of this project. I think that if you're working on models, if you are building machine learning models, the interactive computing is very, very important to make it the best your work.
Yeah, I think that the interactive computing is great for exploration or prototype phases, or to have immediate results, and you can easily experiment different stuff without losing a lot of time in recompiling stuff, waiting to load data in memory, because already everything is already loaded. But then on, you have to, if you want to move on an application or build something that then goes to production, you have to re-engineer it. So it's not a good way to build software. It's a good way to prototype and exploration, but then you have to build everything from scratch.
Good point for overview. Yes. To prototype is the best, but not for release in production. Yes.
Also, we are showing using the notebooks in C# for ML, but they can be used for anything currently. The kernel is the full .NET behind, so you can build interactive console application, interactive experimentation. If you just have to prototype something, you can use those notebooks, not rated on ML only.
Yeah, correct.
Okay, we are at the end of this interesting talk.
Yes,
I have something.
My contacts for any questions. Don't worry, feel free to contact me.
What is Microsoft MVP AI and the Intel Innovator Program?
Yeah, Microsoft MVP is the one of the best program of Microsoft to valorize our passion for technologies. We are MVP, and we have a great passion for technology, and in particular for me is MVP for AI, for artificial intelligence. Intel Innovator is a program of Intel for innovation for hardware and software, where we believe in our passion for technology.
Okay, thank you, Antimo.
Thank you, Dino.
I remember everyone that the best way to learn is to share the knowledge. See you the next appointment. Stay tuned. Bye.
Have a good day. Bye bye. Thank you.
Bye-bye. Thank you.